So let's see, I think I had you do number 5 on your own before you left class yesterday. So let's talk about that one first. And so number 5 says air is being pumped into a spherical balloon at a rate of 4.5 cubic feet per minute. Find the rate of change of the radius when the radius is 2 feet. So tell me which formula that you used for number 5. Volume of what? A sphere. And so the formula is V equals what? 4/3 pi r cubed. Okay, so then let's talk about what information that we were given. We have a rate of 4.5 cubic feet per minute. So talk to me in math symbols. What is equal to 4.5? Good. dV over dt. And that is going to be 4.5. And then it says find the rate of change of the radius. So we're looking for dr over dt. And it says when the radius is 2. So when r equals 2, we want to know what dr by dt is. And so if you took the derivative, you should have gotten dv by dt equals 4 pi r squared, dr by dt. And then if you substitute in 4.5 for dv by dt, and you substitute in 2 for r, we're going to solve for dr by dt. So when you get dr by dt by itself, you're going to divide both sides by 16 pi. 4 times 4 gives me 16. We have 16 pi on this side. So we get 4.5 over 16 pi. Now, if this were a free response question on the AP exam, we can just leave that because they don't count off for not simplifying your answers. But as we know with multiple choice, they normally have you write it in a form that would not include a decimal inside a fraction. Normally wouldn't see this as a multiple choice answer. So to be able to clear that, you would change the 4/5 to 9/2 divided by 16 pi. And then 9 over 2 times 1 over 16 pi gives us 9 over 32 pi is how it will be written on a multiple choice question. Again, free response, you can leave it as 4.5 over 16 pi and they would give you full credit for that. But on a multiple choice question, you would probably need to take it all the way out so that you don't have a decimal inside a fraction. Can somebody talk to me about units?
Feet cubed per minute.
Close.
Feet per minute.
Oh wait, no, feet per minute.
It's just feet per minute because what we're finding is dr by dt, and so the radius is measured in plain old feet and time is measured in minutes. So dv by dt is measured in feet cubed per minute because volume is measured in feet cubed, but the radius is measured in plain old feet. Okay, so that's what you should have for number 5. Hopefully if you didn't have that, you fixed it for me on your notes. And now let's look at number 6. For number 6, it says if a snowball melts so that its surface area decreases at a rate of 1 centimeter squared per minute, find the rate at which the diameter decreases when the diameter is 10 centimeters. All right, so let's talk about what formula that we need here. Surface area of a sphere. Okay, so according to our formula sheet, what is the formula for surface area of a sphere?
4 pi r squared.
S equals 4 pi r squared. All right. Now let's talk about what we know. It says the surface area decreases at a rate of 1 centimeter squared per minute. Keyword here being decreases and, of course, rate. So what would that mean in math symbols?
dr of dt equals -1.
Okay, so it's the rate of the surface area, right? So ds by dt equals 1, but since it's decreasing, we're going to say -1. Good. And then it says find the rate at which the diameter decreases. So what we're trying to find is dd by dt. Okay, and it says that the diameter, or when the diameter is 10 centimeters, so d equals 10. Now these last two problems are a little more involved than the ones that we went over yesterday, in that sometimes the formula that you're using requires a little tweaking before you take the derivative. And in this case, you'll notice that if I were to take the derivative as is, I would have ds by dt equals 8 pi r dr by dt. But those are variables that I don't really know anything about. I could find r, but dr by dt I'm not really sure about. So what I would suggest doing, one way to do it, is to change your formula so that instead of the formula involving r, the radius, it involves the diameter. How does the radius relate to the diameter?
Radius is 1/2 the diameter.
The radius is 1/2 the diameter, that's true. So up here at the top I'm going to say radius equals 1/2 the diameter, or d over 2, diameter over 2. And so if I tweak my formula a little bit, 4 pi, instead of r squared, I'm going to put d over 2 squared, which means that the surface area is 4 pi times d squared over 4. And the 4's actually cancel. And so I get the surface area equals pi d squared. Everybody okay so far? So all I've really done is I've changed my surface area formula to involving diameter instead of radius because of the information that I'm given. Now I'm ready to take the derivative. So ds by dt is equal to 2 pi d, what? dd by dt. And so then if I sub in, I get 2 pi times 10 times the -1, which is -20 pi. And if we talk about units of measure,
It's
oh, you know what? I'm sorry. I subbed in -1 for dd. I should have substituted in for what?
for ds.
ds. Let me fix that real quick. This should still be dd. We're solving for dd by dt, not ds by dt. So this should be dd by dt, and ds by dt is -1. So what does that mean that my dd by dt is equal to? Good, -1 over 20 pi. Now talk to me about units.
Centimeters per minute.
Centimeters per minute, good. So -1 over 20 pi, make sure both the 20 and the pi are in the denominator. And it's centimeters per minute because diameter is measured in centimeters for this problem and time is measured in minutes for this problem. All right, moving on to number 7. It says gravel is being dumped from a conveyor belt at a rate of 30 feet cubed per minute. Now remember, this is the example I started with yesterday and said by the end of this lesson, you'll be able to answer this question. Gravel is being dumped from a conveyor belt at a rate of 30 feet cubed per minute, and its coarseness is such that it forms a pile in the shape of a cone, whose base diameter and height are always equal. How fast is the height of the pile increasing while the pile is 10 feet high? And I went ahead and just underlined my important components as I read through the question. Now, my question for you is which formula should we use here?
Volume of a cone.
Volume of a cone. So if you look at your formula sheet that I gave you, what is the formula for the volume of a cone?
1/3 pi squared of h.
Let me check something real quick. Before we move on. Okay. All right, here we go. So now let's change our sentences to math symbols. Again, the first thing it tells us is that it's being dumped at a rate of 30 feet cubed per minute.
So dv by dt.
So dv by dt equals 30, good. And a clue, even though it doesn't say the volume is increasing, a clue is if you look at the units of measure, feet cubed per minute would imply it's dv by dt. And it says, what else? How fast is the height of the pile increasing? So what am I finding?
Or dh.
dH by dt. I want to know the rate the pile is increasing. I'm finding dH by dt, and pile is 10 feet high. What does that tell me? H is 10, good. And now there's a piece of information that I haven't underlined that we would definitely have to take into consideration. It says that the base diameter and the height are always equal. That is super important. So the diameter is equal to the height. Okay, so I don't really have a diameter in my formula, but I do have radius, and we just said that radius is half the diameter, so that means diameter is 2 what? 2r. Diameter is 2r. If the radius is d over 2, the diameter is 2r. Everybody follow me? Diameter is twice the radius. So I'm going to say, this is going to be my little box here. If I know diameter equals height, then I know twice the radius is equal to the height. And so, let's see. What would we sub in for r? H over 2 or 1/2 h, right? H over 2 would be my radius. Is everybody okay with that? What I'm doing is I am tweaking my formula again before I ever take the derivative. And the reason I'm doing that is because if I take the derivative right now, I'm going to have to do product rule. And when I do product rule, I'm going to have a dr by dt and a dh by dt. I don't know dh by dt and I don't know dr by dt either. So I don't want to have two variables that I don't know anything about. So that's why I'm having to tweak it before I move forward. Okay, so let's do it. V equals 1/3 pi times h over 2 squared times h, which means V is 1/3 pi h cubed over 4. Oh, nope, just kidding. Is that right? Yes.
Yeah.
Yes, it is. H squared, and then I multiplied it times the h on the outside.
Yeah.
So h squared times h is h cubed. I went ahead and did that. You with me now? Okay. And then I'm going to say 1/12 pi h cubed, because I'm going to multiply my 1/3 and my 1/4 together. Again, no calculus yet in this. All I'm doing here is algebra. I say all I'm doing, but we know that's the hardest part, don't we? We know the algebra and the tweaking is the hard part. Calculus is easy, right?
I agree with the other
If
one.
we take the algebra away. All right, so now we're ready to take the derivative. dv by dt equals what? 1/4 pi h
Squared
squared
times dh by dt.
times dh by dt. dh by dt is what I'm solving for. dv by dt is 30. H is 10, and I don't know what dh by dt is. So we have 30 equals 1/4 times 100, 25 pi dh by dt. So everybody agree with me that dh by dt is equal to 6/5 pi. 30 over 25 reduces to 6/5. And the unit of measurement here would be feet per minute. Okay, so the problems that I am adding on for tonight's homework are going to be on the same page, but you're going to do 21 through 24 for me. Same page, but add on 21 through 24. Bless you.
We just add that to the same one.
Yep, just add it to the same page from last night's homework. And do what now? 21 through 24, yeah. Numbers 21 through 24 added to last night's homework. Same page and everything. Now, I would like you to get out last night's homework, and I'm going to give you the answer to number 20 since it was the only even problem. Oh, was 4 on there too?
Yes.
Oh, 4 and 20 then. I'll give you 4 and 20, and then I'll work out any of the ones that you had trouble with from last night's homework. Okay, let's see. So 4 part A was -6. 4 part B was 3/2. How'd we do? -6 and 3/2. Good? -6 and 3/2 for number 4. Number 20, part A, was 9 centimeters cubed per second. And 20 part B was 900 centimeters cubed per second. So 9 cubic centimeters per second and 900 centimeters cubed per second. Yes,
Can we do 20 part E?
sure, we can do as many as you guys want to see worked out. I'd be happy to.
I got part A right.
Part A is correct, so let's look at part B. All right. I'm just trying to find the question here. Here we go. All right. So, part B. So 20 says all edges of a cube are expanding at a rate of 3 centimeters per second. How fast is the volume changing when each edge is 1 centimeter and then 10 centimeters? So tell me what formula you guys used on number 20. V equals S cubed. Good. And so what I know about number 20 is that my edges, or sometimes called side, little s, is expanding at a rate of 3 centimeters per second. So ds by dt equals 3. we want to know dv by dt. That's what we don't know. And for B part, it is at 10 centimeters. So side equals 10. Well, dv by dt equals 3s squared ds by dt. Everybody okay so far? And then if I sub in 10 for s and square it. And then multiply that by 3, because that's my ds by dt. And so that gives me 3 times 100 is 300, times 3 is 900. And since we solved for dv by dt, that's centimeters cubed per, what was the time measured in for that one? Second. Did you see where you missed it? Yeah. Okay, which other ones?
7.
Sure. Number 7, good old trig function, huh? Number 7 is y equals tangent of x. And let's see what it's asking us to do. It says a point is moving along the graph of the function so that dx by dt is 2. And it says find dy by dt. That's what I don't know. For the specified values of x. So for part A, they're telling us that x equals negative pi over 3. Scoop that up a little bit. All right, so for dy by dt equals, what's the derivative of tangent?
Squared.
Okay, secant squared x, and then we tag on dx by dt, since we're taking the derivative with respect to t. And then we're going to find out what dy by dt by subbing in negative pi over 3 for x, and then squaring it. Remember, secant squared just means secant of x quantity all squared. And then dx by dt, they told us in the directions, was equal to 2. Now, I'm going to pull out my unit circle just so I can remind you of something on the unit circle here, but remember, you wouldn't have a unit circle to use. You would want to know the values on there. But just remember that negative angles are measured in a clockwise direction. So positive pi over 3 is up here at 60 degrees. Here's positive pi over 3. So that means negative pi over 3 is 60 degrees in the clockwise direction. So it's down here at 5 pi over 3 or 300 degrees. So this is where my negative pi over 3 is on the unit circle. So my order of pair is 1/2 negative square root of 3 over 2. So what's secant of that value? 1 over 1/2, right? Because it's the reciprocal of cosine, right? And so that just really means to flip the x coordinate, which is going to be 2. 1 divided by half is just 2. So my secant value is 2 there. So I have 2 squared times 2, which gives me 8 for part A. Do you want to see the other parts, or that's good?
That's fine.
Okay.
Can you do C?
Sure. On that same problem, can you tell me what the value, x value is there? Do you have that, or you don't have it?
X equals 0.
What is it?
7. Or do you need C? Is
7c.
X equals 0.
X equals 0? Okay. So we're going to do the same thing. We're just going to use this first step that we already have, and we're just going to put 0 in for our x value. So it's going to look like secant of 0 squared times 2. And so secant of 0 is just 1, because cosine is 1. And when you flip 1 over 1, you still get 1 over 1. And so 1 squared times 2 just gives me 2 for my answer. Yes?
Can we do 19?
Sure. So 19, let's see. talking about a spherical balloon. I'm gonna have to grab another sheet here. Okay, so 19 says a spherical balloon is inflated with gas at a rate of 800 cubic centimeters per minute. How fast is the radius increasing at the instant the radius is 30 centimeters and then 60 centimeters? So I know I'm doing volume of a sphere. So what's the formula for volume of a sphere? 4/3 pi r cubed. Good. 4/3 pi r cubed. And again, that will be given to you. And it says it's being inflated with gas at a rate of 800 cubic centimeters per minute. So dV by dt equals 800. We want to know dr by dt for part A when r equals 30. So I'm going to take the derivative over here. dV by dt equals 3 pi r squared, or 4 pi r squared, isn't it? Bring your 3 down. 3 times 4/3 is just going to be 4 pi r squared times dr by dt. And then I'm going to sub in 800 for dV by dt, and I'm going to substitute in 30 for r. And I don't know what dr by dt is. That's what I'm solving for. So I have 800 equals 900 times 4, that'd be 3,600 pi. Is my calculator working this morning? 4 times 30 squared, 3,600. And then I'm going to divide both sides by 3,600 pi to get dr by dt by itself. And then that will simplify to what? 2 over 9 pi. And make sure that you put that pi in the denominator, not out to the side, okay? 2 over 9 pi. And units of measurement for this one should be centimeters per minute. Does that make sense? Yeah. Okay, do we have other questions that we want to see worked out from last night? No? 7 I've done already, except for, I think the only one I didn't do was part B. So 7 is the one I did here. So number 7, here's A and part C. And then for part B, all you would do is take that same equation and substitute in negative pi over 4 in the place of x. So for part B, we would do secant of negative pi over 4 quantity squared times 2. Notice in the directions it says that dx by dt is 2, so I've used 2 for all 3 parts on number 7. Then secant of negative pi over 4, remember again, negative angles are measured in the clockwise direction. Pi over 4 is, positive pi over 4 is up at 45 degrees. So negative pi over 4 is going to be down at 7 pi over 4 on the unit circle. The x value there is square root of 2 over 2. So when you flip square root of 2 over 2, you get 2 over square root of 2. And we're going to square that times 2. So that's 4 over 2 times 2, which gives us 4. Anything else on last night's homework that you can think of? Well, in addition to the 3 problems that I gave you for tonight, I have a take-home quiz for you.
I
Over section 2, I know you're excited. Over 2.6, okay? It's 5 problems that I want you to do for me tonight and bring it back to me tomorrow. Okay? It's a take-home quiz counting for assessment points. Yes, you may use your notes. It's just the last one. Don't be too scared. No, it's just the last one. So there are 5 related rates problems that I want you to work for me tonight, bring back tomorrow. And again, this will count for assessment points. And then tomorrow we're going to start chapter 3. This will officially wrap up chapter 2. I thought section 2.6 was such an important topic that I wanted to quiz you over just all of your basic rules first, or test you over the basic rules first, 2.1, 2.5. And then I always do 2.6 as kind of a standalone section because it's the application problems and stuff. So that's why you're getting a quiz over just 2.6. And again, you'll bring this back to me tomorrow, and we'll start chapter 3. Get excited.
How many chapters are there total?
Yes, that all the seniors will have the quiz because I'm going to track them down today. Make sure that they have it. You do? Will you remember to give it to me? Okay.
This is the part where it's actually, comprehensible.
And it's something that we actually use in everyday life. Not every day, but like sometimes.
How you're like every
In comparison.
Just like, if physics is everyday life,
Yeah.
maybe.
And you would have to have more information.
Yeah.
For my uncle,
Yes.
that isn't.
But absolutely.
Sure.
If that were the
My
situation,
uncle
you would
was
have to
like,
product.
physics is
Miss
life.
How
Yes.
many chapters
Physics
are
is
there?
love.
How many chapters are there? There are,
Like that we will do this year. 20,000.
no, no. There are, now let me think. There are 5 full chapters. And then we'll do a couple of sections from chapter 6 and a couple of sections from chapter 7. So we'll have another unit after 5 that's made up of just kind of a hodgepodge of sections. So it's like 6 unit tests. And then after we finish the content, that's when we start prepping for the exam.
Okay.
And so, if you remember, hey,
Jason, are you coming to talk about O first priority? Oh, I'm sorry.
hey.
Oh, yeah, maybe do be good.
So, plugs are supposed to be at 9:40 today. But anyway, after we do that, we'll actually, after we've learned all the content, we'll apply it to things and start really practicing pre-response. And so you'll still be learning, but you'll have all the basic content knowledge at that point after we finish up chapter 6. Which
February.
I'm hoping will be in February, yes. Sure. Yeah, and actually I have videotaped today so that you guys can watch. I'm gonna try to upload it to Edmodo right now during the period, and I'll let you know if it doesn't. I'm gonna have to share a folder with you, like a Google Drive folder.
It all works.
That worked good, so I think.
Came up and then just loaded on.
Okay, and then you'll need this because we're having, this is a take-home quiz for 2.6. Let me stop this video for just a second.
It's just, you got like this point